Okay, so if there's no other questions, I'm going to jump back here because I want to get into the Azure stuff. So we kind of saw how the command flowed. Single command goes to a domain, could raise multiple events handled by multiple handlers potentially, pushing down to the read model. So it's a very, straight path getting down to that read model. Again, we talked about all the different major objects, commands. They're always in the imperative tone in terms of that convention. You don't have to, but that's the convention. You're telling your system what you want to do. And it's mapping to your aggregate runes constructor or a specific method within there. But there's no logic with those commands. It's just messages. My domain. The domain is really the aggregate rune, and that's where my business logic is housed. So my business rules in terms of what free space, do I apply a free space or not? Is this card, does it make sense to have the right number of squares? Well, that should have been taken care of ahead of time. But those business rules should be applied there. And generally, you're not going to expose that to the client. Of course, there's always exceptions to the rules. Events, again, another set of messages. This time they're originating from the domain. They're similar to commands, but they have a different intent. The command tells the system what it wants to do or what's to be done. The events tell the event handlers what has been done. So in a very simple system, your commands and events may look very similar. As your system becomes more complex, those commands and those events will become different, and they'll begin to diverge from each other. And then lastly, your denormalizer, your event handlers. This is really the workhorse in terms of pushing the information into the data store. It's handling the events, it's reading them, and basically it's taking all that information from those events, and it has enough information from those events in order to update the read model. There really shouldn't be any additional querying that happens in order to figure out what needs to be pushed into that read model. And again, the read side flow is very simple. It's really just the client going through whatever your provider may be, ADO.NET, like the SQL, a data service, who knows, to the read model and coming right back up. So again, this is the easy part of the application, and hopefully the fast part too. So where can I use CQRS? And pretty much the answer is kind of wherever you want. Windows apps, services, web apps, cloud-based apps, it really doesn't matter. The architecture is not tied to a specific platform or a specific type of application. There's a lot of different uses. But I will say that it's not good for everything. So this is not the magic bullet that fixes all of our problems. There are, Udi Dahan had an article on his blog maybe 6 months ago or something like that, where he basically was discouraging people from using CQRS, even though he's a big player in that space. Because I think he's probably seeing people use it for things that maybe it's not needed for, or they're overusing it. So it's not used for everything. I wouldn't use it for everything. But really for your mid, larger size applications, it may be a possibility. It may be something to explore. And if you start working with Azure, I think you'll start seeing how it can make sense, and you can really take advantage of the features within Azure to start building some interesting applications with it.
David, we've got another question.
Oh, no.
So it says, what value does Event Store add, and what future scenarios might make that valuable?
I didn't hear. Do events add or do Event Store add?
Event Store.
Oh. I will say that's a lengthy topic, but really what Event Stores allow you to do is it allows you to have essentially a record of everything that's happened in your system over time. So you can it's almost like a history of your system from day one. What events, what actions have happened within your system over time. So really it's a if you need to do auditing, that kind of stuff, this is a great this is a killer audit log. Basically, but it allows you to kind of replay events too, and that gets into the whole aspect of event sourcing. And I don't think it's really necessary. It's not necessary with CQRS. You really don't have to use it. I will say that I'm not a huge user of it. It's contained within my within CQRS. It's part of that framework. I don't take advantage of it a great deal. I probably should at some point in time just to get more familiar with it. But what it really allows you to do is I can take that event store and kind of wipe out my read model and replay all those events that have happened and have an exact replica of my read store basically from any point in time. So if I have 2 years worth of events in my event store, and I know something has gone wrong in the past year, I can replay all those events up from the past year and maybe see what's started to go wrong or where some issues have come in or some interesting data has been introduced into the system. So event store is really, it's a big audit log, but it's more than just that. It allows you to kind of replay all the actions within your system from a point in time. So I hope that answers your question.
Okay, thank you.
Okay. And all right, so getting back into hosting CQRS in Azure. And this is my opinion. I'm sure there's others out there. I would say typically you'd want to have two roles in your application, a web role and a worker role. You can kind of combine them all in a single role if you're just starting out, if you just want to test some things out. But I think having that separation of roles really allows you to have that flexibility in terms of scalability. If you need to scale out your website if you're getting hammered, or maybe your commands are taking longer to process and you want to scale out the worker side. So that flexibility, I think, gives you some flexibility there. So I would recommend, excuse me, two roles for that. I'm going to go forward. So again, I had this diagram before, but now we kind of know what the different pieces do. Hopefully this makes a little bit more sense in terms of what's really being done by the web role. And the web role, again, is pretty simple. It probably would be a lesser class of instance than your worker role, perhaps. So the web role is really doing nothing more than creating commands, handing them off to the command service, and doing the querying of your data store. So there's not a lot going on there. Of course, it has to package data up, but there's not really heavy duty processing for the most part. That's really going to be done on your worker role side, where you're applying business rules and maybe you need to, send off, you're calling out to external services or, mailing stuff or whatever that may be. So the worker role might be the more heavy duty side. This is where you may want a medium-sized instance or a large instance, where the web role maybe you have 2 or 3 smaller instances, splitting that up. And then, of course, your SQL Azure could be your read model, or whatever you may want it to be. So because of that, the normalizer is flattening out that data. This could very well be table storage. I believe Renee Abdelin's, his project is called Locad for CQRS, and I believe he allows that your read model is kept in Azure storage or Azure table storage. I haven't gotten that far yet. I haven't been that adventurous to try that. I've stayed kind of safe with SQL Azure in terms of my data repository. I grew up in SQL, so I know it. I'm familiar with it. It's comfortable. But there's really, since you're dealing with flat data, there's no reason this couldn't be table storage. So you have a number of different options, a number of different features in Azure that you can take advantage of to really structure this application according to your needs and however you probably see fit. So the big question is, how do I issue commands from my web role? So, we have this little black line between client and command service. And what does that really entail? What is that line? How does the controller call the command service? We saw in the code that I had this enqueue command method being called, but what's really going on behind the scenes? How do I hook those two up? And so there's a couple of solutions out there that I've run across. One, some people create WCF services on the worker roles side and allow the controller to call that WCF service and pass the command that way. I started off down that road, and I decided not to go that way due to a couple of reasons I'll get to in a second. The second one, you could use a third-party tool, maybe like NService Bus or some other tool like that to kind of facilitate that communication. I've seen some people doing that. And then the third, you could use Azure storage features like blobs, queues, and tables in order to facilitate that communication. So all of those solutions have advantages and disadvantages, and I'm sure there's a handful I've missed, and I'm sure people are coming up with new ones every day. But I initially started down the road of WCF service, but I didn't really care for that too much because there's still that element of coupling. So if I go back to here, there's still that element of coupling between that client and the command service. And I think in the next slide I'll kind of show that a little bit better. So it works. There's no reason it wouldn't work. But I didn't feel as comfortable with this, this communicating line here being a WCF service. So I opted to go more for the Azure storage aspect of it.